Okay, welcome everyone. Today we will study the stress on a sample, but this sample cut at an angle. We are not on a surface that has been cut in a normal or tangent usual plane. Okay, so let's study this. Draw. Remember the tip. What do you need to do first? Always. Free body diagram. Want to take the bottom or the top part? Doesn't matter. Let's use the bottom part. So I have this sample, and just to show you a little bit better, it's kind of, like a 3D part, like this. Okay. And there, this is a thread, so the sample could be attached and pull on it. So what do we know? We know the force P, 15.9 kilopounds, the same. Okay, 15.5, 15.9. So now we need to study this little surface there. Okay, we have this surface like this, and we have this angle theta. So in this case, we are on the bottom, but if we take the top, the angle theta is there. So this is the angle theta, and this is the force, 15.9 kilopound. Here we go. So the questions is, let me double check the questions. Find the average normal and average shear stress acting on the area of the inclined failure plane and the stress acting on the cross sections. So let's work on the inclined plane. Okay. So normal and shear stress. Normal, we need to draw the normal axis. Here we go. This is the normal axis, and that will be your shear axis. Okay, so if we look at the angle, this angle is, that's where the tricky part is. The angle is there. So the angle is also, theta is also there. Okay, draw parallel line. So if theta is there, this is 90 minus theta. This is also theta there. So what can we write? We can write that on n, so on n, that's your normal, right? So your normal equal p cosine theta. So that will be n equal 15.9 cosine. In our case, in our example, the angle will be 50 degrees. Okay, so I'm sorry, I just like I need to find a way to not click on anything. So for n, that will be 10.2. Oops. It's keep. Oops. And for the value on the tangent plane, okay, so for the V, the shearing forces, that will be, if we look at this triangle, that will be the opposite angle. So that will be P sine theta. So V equals 15.9 cosine 50. And you get your V equal 12.2. Oh, sine. Sorry, sine. Right, too fast. Sine. Don't change the cosine and the sine. 12.2 kilopound. Here we go. So now that we have those values, we can find the stress and the shear. Those N and V are forces. We want the shear and the stress. So that will be we need to divide that by the surface, by the area. And this area, how much is this area? So this is, well, so it's a little bit tricky. So we want to find this area there. Okay? Not the area that was perpendicular to the road, but the area that is at an angle, like this. Okay, remember this angle theta is this angle there. So this is the area A, and the A will be your pi r square. So in this case, that was pi times 0.375 divided by 2 square. So this is your area. But this one, let's call that A prime. we can see that this is a cosine. So we have cosine of the angle that's equal to the tangent, that is A, divided by the hypotenuse, that is the A prime. So the A prime equal A divided by cosine theta. So A prime equal pi times 0.375 divided by 2. Oops, you find some space. Square and everything divided by cosine theta. So the first one equal to, don't forget the cosine theta, theta is 50. So this one was 0.1104 inches square. And this one equal 0.1718 inches square. Does that make sense that it's larger? Yes, definitely the area in that axis is larger. The area at an angle is larger. Okay, so now we can find the stress and the shear. Remember the formula for the stress? You try to use as much space as possible. I will go there. So the sigma equal what? The normal force divided by the area. So N divided by the A prime. The N is 10.2 and the A prime is 0.1718. So sigma equal 59.5. And don't forget it was kilopounds, so that would be kilo KSI. Okay. Okay, so kilo pound per square unit. And tau, it's equal to the V divided by the A prime. That will be 12.2 divided by 0.1718. So it's equal to 70.9 kilo pound per square inch. Here we go. And there was one last question. I will make it there. So the question was, what is also the stress acting on the cross section? So the cross sections is this one. So the stress on the cross sections, that will be very simply. So this is the tau prime and sigma prime and tau prime. So the sigma will be the P divided by the current area, like the cross sections area. So the P, it's the 15.9 divided by the area that we found the first one, so 0.1104. So that would be 144 KSI, and the tau, because there was no perpendicular force, that will be 0. So let me reorganize a little bit this for your paper. Oops, no. Oops, that was 0. So we will have all this data there going here. So what did we do? Remember what we do? Always the same steps. Free body diagram, the equation. So here is not really an equation of equilibrium. What we just try to find is like in these steps, we found P on the axis N and on the axis V. So on the normal axis to the plane, to the inclined plane, and on the tangent axis to the plane, where the shear. And we found the area. So the area A, in this step we found the area A and the area A prime, the section as an angle. And third steps we found the stress and the shear. And that's it. And just be careful about something, your angle theta, or like, it doesn't matter if the angle that you have is this theta there, or maybe the theta on, that will be the other side, so this one. But just be careful of your cosine and sine, because that depends of which side did you look at it, which side is theta given, okay? So maybe in some problems the theta that is given is not the same. It will not be the cosine and the sine for your P and your V will not be the same, okay? Just a little, be careful, little tip. Hope that makes sense. Bye-bye.